Hi, and welcome to this next video in the algebra section. And what we're going to be doing in this video is looking at how we write formulas. So in the previous one, we're given some formulae and said, okay, can we put the numbers into the formula? In this one, we're actually going to be given a situation and we've got to come up with the formula ourselves. So let's have a look at an example. So as I said before, in the test we might be expected to describe a situation using the formula that we've created. So here we go. So here's our friend here. She's having a dinner party. And the tables are going to be arranged like that. So, she's saying that if we've got 4 tables, we've got enough seats for 18 people. So we can see we've got 1, 2, 3, 4, 5, 6, 7, 8 there, another 8 there, and there's our extra 2 on the ends there. So, the question goes, well, here we've got 4 tables, 1, 2, 3, 4. What would happen if I had 7 tables? So let's first of all, we'll just do a bit of working out with the numbers and use this to help us figure out how the formula is going to work. So let's first of all answer this question. How many people could she invite if she had 7 tables? Well, if we think about each table, let's say this one here, there it is, has got 4 people on it. So there's our 4 people. So each table seats 4, so that would give us 28 people so far. But then that's just for the tables in the middle, for example, that one and that one. We've also got the ones on the end. We've got these 2 guys who are going to be sitting on the ends of the table, presumably the most important people. So there we've got those 28 people, but then we've got room for those extra 2 that are going to be on the ends. There they are. So in total, she could invite 30 people to sit round a table plan with 7 tables. Okay, so on we go. So same kind of question, but how many people could she invite if she had 20 tables? So let's have a look at that one. So there's our 4 people per table. So we've got 4 per table, plus we know we've got the 2 on the ends. So for 20 tables, that gives us 4 times 20 plus the 2, which is 82 people. And you can start to see how I've written here, we've got the 4 people per table, which is that bit there, plus the 2 extra people, which is that bit there. So already we're starting to see there's a kind of structure or a formula for how we can work this out. So the question would be, and where we're heading with this one is there any way you could work out the number of people for any number of tables at all? So what we're going to do now is go from a specific number of tables here to a rule that will work for any number of tables whatsoever. So if we take this rule and write it just in words, which is essentially what we've got up here, we've got the number of people is 4 times the number of tables plus 2. So 4 times the number of tables plus the 2. So that's basically that thing there. So what we're going to do is use a letter to represent the different parts of this. So here we go. So we've got P is going to be the number of people. I've used a P for that one. And T is going to be the number of tables. So here we've got number of people. That's going to be P. Number of tables over here. That's going to be T. So let's see what our formula would look like. So what we're going to do essentially is translate this statement here from words into something that's written mathematically using algebra. So let's start off with the P, the number of people. That's P. Is, that's going to be an equal sign. And now we've got 4 times the number of tables. So that's going to be 4 times T, or 4T. And then the last bit at the end is the plus 2. And there you go. There's our rule. Okay, so let's do one more example. So here we go. Jesse's got some pencil in the pencil case. Leanne has 4 more than Jesse, and Perry has 3 times as many as Leanne. Which of the following is an expression of the number of pencils that Perry has? So what I'm going to do here is give you some choices. So which of these expressions will allow us to work out how many pencils that Perry has? So here we go, let's have a look. So let's start off at the beginning. So Jessie has got some pencil in the pencil case, and we're going to say that she's got J pencils. So we're going to use J to represent the number of pencils that she's got. In the same way as in the last example, we used T to represent the number of tables, P to represent the number of people. Now we're going to use J. It really doesn't matter what letter you use. We're going to use J to represent the number of pencils that Jessie has got. So that's Jessie's pencil case. She's got J pencils, however many that is. And now let's think about Leanne. She's got the same as Jessie, but then another extra 4. So her pencil case is going to have that many pencils in it, J plus 4. Okay, and then finally, let's think about Perry. Now, Perry's got a whoop load of pencils. She's got 3 times as many as Leanne's got. So, here we go. There's her pencil case. Effectively, she's got 3 lots of what Leanne has got. So, there they are. So, now we've got to say, well, how many pencils does she have altogether? She took each of these and put them all in one pencil case. So, how many J's have we got? Well, that's going to give us 3 J's. And then we've got 4 plus 4 plus 4. So we've got 12. So the one we've got is that one there, 3J plus 12. So that's the one that represents the number of pencils that Perry has got. Okay, the last thing I want to do is just look at that last bit again where we said about the 3 pencil cases that Perry's got. So there they are. There's our 3 pencil cases. And she's got 3 lots of J plus 4. So 3 lots of that. Now, in maths, brackets are kind of the maths version of what we've got inside the pencil case. So if I wanted to write this thing here mathematically, or effectively this statement here mathematically, so, well, you know what, I've got J plus 4, stick them inside the brackets, so actually there's our pencil cases, yeah, and I want 3 lots of all of this, and so 3 times everything inside the pencil case. Now, the reason this is important, if I didn't have these brackets here, I'd have 3 times J, but I wouldn't have 3 times 4. We need 3 lots of everything. So let's work out what happens now when what we say is we multiply out the brackets. So here we go. So 3 times J. There's our 3J. And now the other bit I've got to do is 3 times 4. There it is. And 3 times 4 is 12. So there's the 3J plus 12.